we have compromised our target client, which was an employee. And the second one is our server. And firstly, we use Patak to get this implant running using Patak service. Then we used Meterpreter through Patak. We stole the system token and we just started Meterpreter using that token. Then we used Meterpreter to tunnel our traffic. And now we compromised two systems and looking for the third one. The third one is our Linux system. And we have identified this using HTTP version attempt. So we know that the second server has a HTTP service running. So let's use one of our sessions and Meterpreter's feature. For example, session 4 is good. And we have a route defined for this network. So whenever we try to achieve anything through Metasploit, they will use this route. However, the web service itself presents a web page. That's what we try to achieve as well, because what we were expecting was a financial application running on this Linux server. A financial application on this web service. Let's find this out. Port forward is another feature of Meterpreter. So we can initiate a port, listen to port 8081 and redirect this to remote host and on their port 80. So we initiated a relay here. Meterpreter will listen to port 8081 on our attacker system, and whenever it receives a connection request, it will forward this request to the server. Simply, we are talking about this diagram now. Meterpreter is tunneling this traffic for us. And now we use this using port forwarding as well, so the other applications can reach. Port 8081 is available on localhost. So we can see this works or not. It works well. And this is the financial application we see. And it is useful. And we can do a lot of different things here. And let's see the final application and what we can do with that. So what we can do here is slightly simple. If we look for the credentials we acquired, they are here. If we remember with Chihuahua sitting here, we call it Chewbacca. And also this password, we can connect to it. Yes, save it. That's great. So what we can do here is good. Getting in, but this doesn't mean that we have everything aligned. So we need to find some stuff here. We need to find some data or something, because we know that we have compromised the environment and we receive the files such as Jack of Hearts or Seven of Spades. They are with us and they are coming from the Windows server. And we have a Linux server, the application service logon, which is, in our point of view, a simple Swift application that allows us to initiate a transfer. And we use the credential extracted from the Windows. But that could be a credential saved on the employee as well. And generally, that is the case. The users save their credentials in some repositories, such as browser or text files, or sometimes a safe box, a kind of safe application, but we can still extract the data. But the thing is, we can still use this for SQL injections. or some other vulnerabilities. And we can see that whether or not this will work. And it somehow failed. Maybe we can use something like this. Or can be used. And we simply change the username, and there was a condition there saying that if the username is equal to something, which is nil in this case, or 1 is equal to 1, which is always true, and it allows us to get in. It doesn't wait for the password authentication. And this simply shows us all the users. And there's another injection here. And this injection is also another known injection. And I'm just pasting it here for your visibility. It is again or 101, which avoids us to authenticate. So we don't need to give any credentials. It will be valid anyway. And the second part of the query is another union select. So two select queries will merge, and we will see both data. And the second data is username and password coming from the users table. And the hash is actually terminating the query, so it won't fail. If there is any remnant sitting here, there should be, such as password comparison, it should just turn to a command. If we run this command like this, you could see the content, but the second content is here, which is actually the passwords of the users, Jar Jar Binks, and we can confirm this through Chewbacca. As we can see the Chewbacca here. If that is the case, the others must be the passwords of the other users. That is what we can do with the web application-based vulnerabilities. So we simply compromised the second system, second server in the back. So we have access to the juicy data, and we have almost everything. So if we have Swift application to commence a transaction, if we have the files extracted already, the sensitive files, and if we have the files encrypted here, our actions are done almost, right? We don't need any additional objectives here. But for the argument's sake, we can still get a shell and we can make it root as well. So let's go back and look at our sessions. Our sessions are still alive, but we don't have any Linux session here. Our network is still routing through the session 1, and we can do stuff. For example, we can use auxiliary admin SSH credentials, or we can just search for SSH login. So we can use its name directly here. SSH login is here. What it does is quite simple. If there's any username and password given, or any dictionary, it can be used to log on to remote SSH server. And we know that that is a Linux, and there is a kind of SSH possibly. So we can use our Chewbacca here as username. And its password as well. If we run this, technically it should log on. But there's one thing here. When it logs on, it gives us a shell. I'm adding the remote address, which I forgot in the first place. It may provide another session to us, so we can have an interactive session if it works well. But we don't know if there is any SSH or not. There is no SSH. So we need to find additional vulnerabilities to get this done. So Linux exploitation will be another video then.